Good morning, this is Mr. Morales. I'm going to go over your 6 weeks exam algebra review. So, first question is, use the function below to answer the following. We're given this continuous graph, and we're asked to find the domain and the range. Because it's continuous, I know that my domain will be represented with x, and I'll have my two inequality less than arrows. Now, the domain tells me how far left and right my graph goes before it terminates, if it does. I can tell, though, that this graph, moving to the left, goes on infinitely because I have these arrow tips right here. So because it goes infinitely to the left, that would be a negative infinity, lower level, or limit, excuse me. Now as far as how far it goes to the right, well, I also have an arrow on this end of the graph, which tells me it's going to go infinitely to the right, which is in the positive infinity direction on the x-axis. Don't forget though, however, when you have double infinities like this, you can write the answer this way, or the more popular all real numbers notation. Next, we're asked to find the range of this graph. The range determines how high up or down the graph goes. In this case, the graph, we could see that it hits a little bottom point right here at -2 measured on the y-axis. So I have the range, which is measured with the variable y, my two inequality arrows, and then I know that it hits a bottom at -2. It actually makes contact right there at -2, which means it'll also be equal to that point. After that, my graph goes upward in both the left and right directions infinitely. So that would be positive infinity. Now, here's one way we can write the answer. However, it can be rewritten if you drop the infinity symbol. Excuse me, I forgot what it was there. So what I'm going to do is just drop the symbol off. I'll cover it up. And what I have here is the y. I'll write that over here on the side. I have the open end of my arrow facing it, so greater than or equal to, and then my number, -2. This is probably the more popular way you would see it on an exam. So here's the way we're used to describing it, but here's an alternative way. All I did was just write the variable first, y, and then since y was coming first, I went and switched the arrow opposite direction just to match, because I could see it's open-ended on this side facing the y, so it's open-ended right here also facing the y, and then my number is still the same. Next, I have to find the function value for 3 and 0. Well, that's really easy. We're used to seeing the function notation f of x. So this alone tells us what we're doing. Instead of looking for x, we're looking for when x is equal, in this case, to 3. So I go to the x-axis and I find positive 3. 1, 2, 3. And then now I move up until it touches the graph. It touches the graph right here at a certain point. I'll go ahead and just march on over to the y-axis to get my y value, and I get a positive 2. That means this graph, when x is positive 3, the y value is positive 2, and that's what the coordinates are at that point on the graph. Now I need to find the function value when x is equal to 0. So I go to my x-axis to where it's 0, which is the origin, and I make contact with my function, which is down here at -2. So those are my two values. Moving on, let's go to question number 2. Now we're asked to solve the following equations. And we're given two equations on the left and the right side. So just to go ahead and jump right into it, on the left side of this first equation, I need to apply the distributive property. So 3 times a is 3a. 3 times a positive 6 is a positive 18. I have a plus 12 on the right side. What I'm going to do now is I need to bring those letter a's together. I'll take the side that has the least amount, in this case this side right here, which has a 1a, and I'm going to go ahead and subtract 1a from the right and the left side to balance everything out. By doing that, subtracting 1a on the right and minus 1a on the left, what I get is 2a plus 18 on the left side equals, my letter a's cancel out right here, and the number 12 drops down. Now it's just a two-step equation. I'm going to subtract 18 from both sides. When I do that, I have the 2a falls down. Equal sign. 12 minus 18 is a -6. Divide both sides by 2 to isolate the a by itself. And then I get 2 divided by 2 is 1a equals -6 divided by 2 is -3. There's my first answer. Now I'm going to go ahead and work the other side in its very similar fashion. I have distributive property on the left. 6 times 5x is 30x. 6 times a negative 3 is negative 18. Now I know that a little math trick is that when I'm multiplying by 1/3, that's the same thing as dividing by 3. So 1/3 of 24 is going to be, of 24x is going to be 8x. 1/3 of 12 is going to be 4, positive 4 in this case. Now I can go ahead and combine my like terms. I have 30x's over here, 8x's over here. I'm going to remove the smallest amount that I have from either side, which is in this case to subtract 8x's. Subtract 8x's from the right hand side as well as from the left hand side. When I do that, 30x's minus 8x's is 22x's. This negative 18 falls down as a minus 18. 8x minus 8x on the right hand side cancels out, and then this positive 4 falls down. Now I go ahead and I'm going to add 18 to both sides, just using the same methods we learned when we solved two-step equations. My 22x falls down. My minus 18 and plus 18 equals 0. 4 plus 18 is 22. Now I have 22x equals 22. I divide everything by 22. Nice, easy math. I have 1x on the left. 22 divided by 22 is 1. And those are my two answers there. Also, if you remember how to use NSolve, you could use NSolve to solve these two equations. If you don't remember how to do that, go ahead and ask your teacher if they'll let you use it. Moving on. Now we have question number, where are we at now? Number 3. Hopefully this recording is running out of memory before I have to break it up. So another simple function equation. We have g of x equals 6x minus 5. They want us to substitute the x value in this equation with the number 8. So we're solving now for g of 8, which means I'm going to do 6 times 8, because wherever I see an x, I replace it with that number 8, minus 5. Following PEMDAS, 8 times 6 is 48, minus 5, and 48 minus 5 is 43. That'd be a simple plug and chug with your calculator if you remember how to do it. Now let's get into number 4. This one's a little more detailed, so let's go ahead and discuss it. We need to find the sum of 3 consecutive odd integers that equal negative 51. Find the 3 integers. So I'm going to have 3 negative numbers that when I add them up equal negative 51. Well, all I know is that they're odd and they would be in a row. So I'll call the first one that I don't know some number n. Whatever odd number that is,